So now let's discuss that how or what should be the intuition behind obtaining a vector representation. So the early attempts to define meaning of a word or concept, you can look into the, goes back to the 1975 or so. So there, for any word, people try to look into the geometric figures or to represent those words, and based on that, they try to sort of capture some sort of a representation, or they try to define the meaning of a word. For example, mm, in one of the attempts, try to look into this kind of features coming out from the geometry of the geometry representing the the words or the associated with the words. And one of the features you can look into perhaps the relative diameter. Now the question is, when a word at what range of that particular feature, it represents one particular word, and then when and in what range it becomes perhaps to represent another word. So the when we talk about this cup or ball, they have a very similar kind of figure or geometric representations, and when we try to define them. So if you look into the one particular feature like relative diameter and so on, so in that case you will see that in what range it would be more likely to be a cup, and in what range it start to be a more likely to be a ball. Uh, and sometimes it also depends on the context. If uh, there is a food, then most likely it is going to be a ball. And based on that, again, you can see in this particular figure that with and without context, the kind of another diagram, which sort of represents that when something is becoming is more likely to be a ball or a cup. So again, here one clue is that in some kind of a context, it is there that has impact on the meaning of the word. And in some sense, that the Ludwig, who said that the meaning of a word is its actual use in the language. So that's a kind of in some sense, this is a different approach that what we have seen earlier by looking at the geometric figures or geometric characteristics of any word. But in that also, what we have seen is that when we look into some kind of a context, then there is some reflection of the context in its the representation of the meaning of the word, how it changes the what it could be. So that in a kind of the information is also being reflected here, that the meaning of the word or to identify that what we actually mean by a word is basically that how that word is being used in a language. And although this was an idea of a linguist or Ludwig, uh, that has been sort of taken forward and converted into a kind of a more in a formal way, or converted into a more model which we can use in our in machine learning framework. There are multiple computational linguists like Zeus, Harris, and Firth, sort of almost at the same time, we sort of try to say that the word is defined by the distribution in which it occurs. So essentially is that we can define a word by looking at the distribution of the text which are there, which are occurring in its context of that word. So they try to sort of given some examples. So when you look into this oculist and the eye doctor, they tend to occur in almost the same environments. So now you can sort of reflect that what we have discussed about the semantic field. So, uh, so that's what actually they are trying to sort of reflect here, that the oculist and the eye doctor this occur almost in the same environment, and from that, if you look into the words which are surrounding the oculist, or the words which are surrounding the eye doctor, so that's what the distribution of a text is of in around your word. So if they are same, then perhaps their meaning is also being the same. And that's what they have, Harris said, that if A and B have the almost identical environments, then we can say that they are likely to be synonymous. And this is, while describing this, what we call the distributional hypothesis, so which is sort of initiated by the linguist Ludwig, and then made it more popular in, let's say that, in a domain where we can use or obtain a vector representation of words by some of these computational linguists. And Firth sort of has given this kind of a notion that you shall know a word by the company it keeps. That kind of summarizes this hypothesis, what we call is distributional hypothesis. And again, to reflect that, let's look into one of the example, that a bottle of Testino is on the table. And then, when you look into this particular first sentence, we may not be aware that what is the meaning of this particular word. But when we look into the second word, we get some sense. Of course, in the first sentence also, some of the words like the bottle gives some idea that what kind of a thing it can be, because it's kept in a bottle. Okay, then everybody likes it. So maybe it's something which can be eaten, or you can drink or something like that. And then you have this word which says that this makes you drunk. That then it actually start making, you are becoming more clear about the meaning of this particular word. And then finally, when we say that it is made of out of corn, it reflects that what actually it means, or what kind of a the it could be a, like the something which is like whiskey or beer, or that kind of a thing, which is sort of what is being meant here, or the word Testino refers to. So it's kind of an alcoholic beverage. That's what we meant. And even if we don't know, now by looking into these examples in which this particular word has occurred, we know the meaning of it. And this is, we see that often somebody asks us a meaning of a particular word, and if we don't know our first reflection is that, can you tell the sentence where you have seen this word. So basically, by looking at the sentence and a distribution of words which are around that particular word, we try to guess its meaning, and that's what the distributional hypothesis tries to reflect. So that's the end of the first part of our discussion on the vector semantics, and this is the end of this lecture. And I will continue to talk about the models in the next class.